All right, welcome to the February meeting of TriEmbed. I don't see any people who have not been here before, so I don't think we need to do any introductions. For the people that are watching this, I'll mention that as our first announcement that RARS Fest, the local radio ham swap meet, is going to be April 6th at the fairgrounds. And prior to starting the meeting here, we were talking about having a couple of tables there for TriEmbed. Other local maker spaces and such will also have tables there. Other announcements? February 24th, that's about 2 weeks from now, is Engineering Day.
Which museum? Because there's a couple of them coming up.
Well, it's a national holiday kind of a thing.
Yeah, it's a thing that various people are engaged in.
And so the Forge is having some kind of a presentation that day. And Scott, you seem to think that other...
Yeah, Splat Space is participating both with the Museum of Life Sciences, some demonstration tables and science things there. And then also there's I thought the museum in Raleigh also had something going on that day.
Okay.
Also, there's another event coming up, the dinosaurs exhibit in Raleigh. And there's a day there that Splat Space is 3D printing a whole bunch of dinosaur skeletons articulated with robotic parts to walk around.
That's a for-profit group that's in the movie theater off of Pleasant Valley Road or something like that, off of Glenwood Avenue. They have the Monet interactive installation with Monet paintings projected up onto the walls and things, and so they were looking for other things to do, and they're doing this dinosaur exhibit as well. Other announcements?
So there will be an EDGER project meeting on March 2nd, 2 o'clock at the Forge. It will be very development oriented. But if there's something that would be of general interest, we'll include that when the meeting notice goes out.
That's Saturday?
Yes.
Yeah, Saturday afternoon, 2 o'clock at the Forge in Apex.
Okay, I might join you on that one. We'll see.
Are they going? Is it going to be virtual as well, or no?
Yes, it will also.
Combination.
Sorry about that. Yeah, it'll be hybrid. You'll be able to connect to it, and for whatever reason, we haven't been creative enough to come up with our own URL, so we're using the TriEmbed URL for Jitsi.
Other announcements? All right. All right. Do people see this?
Yep, we see it.
Yep.
Hey, you should patent that, Paul.
What?
Volume
video
control.
conferencing that works? Oh,
no, volume controls.
Well, unfortunately it's a problem that I haven't solved. So last month we did some baby toys. My granddaughter just turned 1 last weekend.
Did you make this or you buy this?
It was given to my daughter. And
okay.
She likes it, except it's really loud.
Resistors are your friends.
So I brought it home. Does everybody know what an Egger suit is? Does anybody not know what an Egger suit is? It's from Men in Black.
A what?
Egger suit.
Edgar,
Edgar.
Edgar.
Edgar suit.
It's more Egger.
Oh,
really?
Yeah. So
Maybe turn on closed captioning. Oh,
can't hear me. In Men in Black, the alien comes and takes this farmer named Egger and rips his skin off and wears it around as a suit. So
I remember that now.
This
Oh, yeah.
is after I have done a little surgery on the toy. So here it is. Here's the alien underneath.
So what was loud? Was there like music or sound or talking or
Yeah, there's music. So it
pre-recorded?
operates.
Okay.
It operates in two modes. So here's the little board that's inside. It's got an EEPROM on there that has presumably the music digitized and stored in there. There's a little MOSFET here for driving the electric motor that spins the spine around. There's a microphone, so it will do sampling. You can press the button and say, hello, baby Quinn, and it will say, hello, baby Quinn, hello, baby Quinn.
Was it just repeats what you say?
Yeah. So it samples it.
Yeah, it samples it, puts it on an
And
endless
replays
loop.
it. Yep. Runs on 3 batteries, so 4.5 roughly volts.
These are double A's, yeah.
Yep. So there's the speaker. Looks kind of like a normal speaker. I unsoldered one of the wires and measured the resistance, figuring it would probably be 8 ohms. It was 9.3. That could be my multimeter. It's one of the free ones I got from Harbor Freight. Or maybe the speaker's 9.3 ohms. I don't know. And then it gets mounted in this.
So it's 8 ohms, but that's it's because it's AC, right? Because it's audio.
Yep.
That 8 ohms is not exactly what you measure on the speaker.
Okay. That's interesting. The speaker mounts right there with a little screw to hold it in, and there's some little holes to let the noise out. And so I hooked up my scope, and I assume that each one of these little peaks is some kind of a note that's being played on the speaker. Roughly 4.2 volts tall, which is about the 3 batteries worth. So I don't know anything about audio. I don't know if we're trying to get the voltage down or the current down.
You can probably just put a resistor in series with the speaker. You just have to make sure the resistor can handle the power, but I doubt there's very much power coming out of this.
Or better than that would be a little potentiometer, and basically you could arrange to so that the voltage, so that the output went from no attenuation to a lot of attenuation.
Okay, so the problem with a potentiometer on the speaker directly is that it's very, very low resistance. Matter of fact, if you were to add a resistor, you'd only be adding something between 4 and maybe 16 ohms or something like that.
What I was describing,
LPAD.
Yeah,
the LPAD presents a common impedance to the amplifier, and then variable current to the speaker.
Yeah. Or, well, another way to think of it is providing just an adjustable fraction of the output to the speaker. And
I mean, so I thought of putting a resistor in parallel. So imagine like an 8 ohm resistor in parallel, which would take half of the current and voltage, and then adding another one to bring it back up to the 9 ohms.
Well, so yeah, you can do that, but you'd want to put the resistor in parallel. So you'd want to put a resistor in series and then the one in parallel after the one in series. Otherwise, you're dropping the resistance to the amplifier to a point where you could fry whatever the output drivers are. I used to do a lot of audio stuff back in the day. Another solution is you can actually get you could probably go to AliExpress or whatever and find like a little preamplifier and take the output of this, put it into an amplifier. You definitely have to do something on lowering the power output going into an amplifier. And then the other amplifier could have a regular standard volume control to another speaker. That's the hard way of doing it.
Okay. So the speaker,
Paul, those two links that I just posted up.
Yep.
That second one, could you share that so that the group could see it?
I think so.
I can share it. You mean this?
I just have to get I hate this. So there's a little dialogue that says Jitsi is sharing your screen, which is right on top of.
Grab the two little bars on the
I found it. There it is.
on the left and move that dialogue away.
Okay. Do you want the crossover, or do you want the?
There's a diagram there that explains LPAD and
LPAD attenuators.
There you go. So that kind of explains the connection and stuff.
So it's two ganged resistors.
potentiometers.
Yeah,
potentiometers. Rheostat on the left. Well, they're really rheostats.
Okay.
In those situations, but yeah.
Okay, and the other.
Yeah, that looks like a good idea. Because in this way you're keeping the resistance that the amplifier sees to pretty much the same thing, regardless of where you set the volume.
Exactly. So the speaker's just seeing an adjustable fraction up to the whole thing. And you probably are talking milliwatts. No, I would say
right.
that output is probably a little tiny fraction of a watt. So you don't need to worry about the capacity of the pad.
Another thing you can do, Paul, is, and you've got to play around with this to see what's best. These little amplifiers tend to be very tinny.
Oh yeah, it's very tinny. The whole thing is
right. So something you can do is stick a capacitor across that.
Okay.
In such a way that you attenuate the high frequencies, and you try to flatten out the spectrum, and that'll actually make it sound a little better. But you're also going to
a little one stage filter kind of a thing.
Yeah.
Yeah. Right. Exactly.
So the speaker are these two wires here, these two black ones, and they come from two pins on I assume this is the processor. I was expecting one pin of, digital output or analog output, and the other one would be to ground or something. Does it make sense to you guys why they use 2 pins here?
Yeah, as a matter of fact, I just programmed another circuit where you're alternating between the 2 pins, what's high and what's low, in order to create your wave. You're doing it programmatically, setting one up, one down, then the other one up, and the other one down, to create a kind of a waveform that can float with a pseudo grounding between your ground and VCC. So neither side of the speaker is connected to ground, and you want to make sure you don't.
Yep. So I think that I had, so this is a dual trace scope. I think the red one was on one wire and the yellow was on another wire. And they're referencing to ground, which was on the negative of the battery. So I don't see anything on the red one that looks anything other than ground-like.
You notice in your waveform that crossover going on down the middle?
Yeah. Yep.
That's what the software is doing when it's flipping the terminals.
Okay. So it's kind of creating this
Pseudo ground.
Pseudo-ground in the middle.
You'd see it better if you had expanded out one of those blocks of waves and spread it out.
Yeah. Yeah. That's interesting. Okay. Other ideas?
By the way, I posted a Parts Express link up there for a whole bunch of crossovers. LPads, I'm sorry. And you can get them typically for $8 or less.
And so that would be you just insert that in the 2 wires going from the output to the speaker.
Yep.
Okay. Okay. Other ideas?
Sticky tape over the audio grill.
Yep. Yep. That's a good idea.
Very simple solution.
Yeah.
Cheapest.
Certainly worth a try, right?
Even a piece of foam, rubber kind of foam type thing.
So sticking some acoustic foam on the others, or some foam on the other side of it, as long as I didn't interfere with the motor spinning stuff, might also deaden it, right? There'd be less air to move.
Right, or like a felt pad.
Speaker.
You could use a felt pad type of thing.
Yeah. Other ideas? Poking a hole in the speaker?
Nope.
No, you're going to get distortion.
Not a good idea.
That's how the kinks
at
got
some point
started.
it stops. At some point it stops working, right?
Well, the kinks got started that way, but the sound they were after, I think your baby's not going to enjoy.
And neither will any of the adults.
I think there's already a problem with that.
You could always put a piezo speaker on there.
Replace the speaker. So if, so what would happen if you put a 4 ohm speaker in instead of an 8 ohm? Is that going to make it louder, or
it's going to draw more current and draw down your batteries faster?
Yeah, it would make it louder. It would also it'll also load the amp more. Whether or not it makes any difference because of how small the amp is to begin with, I don't know. But yeah, a lower ohmage speaker with a resistor in series would definitely decrease.
Let's double back to the 8 ohm measurement that Paul made. That actually bears there's no connection between that and the actual impedance. To measure the impedance at audio frequencies would require a different piece of equipment. So we're making a giant assumption that the current speaker is 8 ohms. But you would get indication of that if you did mess around with load resistors and so on to see, in theory, if you put a resistor that you think would match the impedance, then the sound should go down by 3 dB. You're gonna cut the power in half, and that's a just noticeable decrease in the volume.
Okay. I checked
Hey,
my
Kamal, do you want this thing to be softer or louder?
Softer.
Okay.
Yeah, if it were inside of a sealed container, I think the volume would be about right. So I looked in my resistor collection, and the smallest resistor I have that's not, I didn't check my surface mount ones, but so I have a 10 ohm resistor. And so I could try sticking that in. And does it matter which leg I put it on?
Well, putting it in series is kind of a crapshoot as to what the effect's going to be.
Okay. So that,
but if you put something in parallel and you notice a decrease in volume, then you've probably gotten in the ballpark of the impedance involved. The problem is that measuring the DC resistance of the speaker coil isn't valid for
that's
audio.
correct.
Yeah.
Right.
okay, so putting one in parallel will divert a portion of the current, right? And so the speaker will see less, but it also reduces the resistance on the amplifier. And so that's why you want an additional resistor in series to try to recalibrate that load.
If we think that the output impedance is, if we think that the amplifier is actually sensitive to that, my guess is that it's probably
Not very.
yeah, not very. It's probably. I mean, looking back at your circuit board, am I correct in seeing that there isn't actually any audio
Correct.
circuitry on that board?
Right. It comes out of the processor.
Right.
Those two.
So the whole thing's being driven by a digital gate.
A D to A.
Right.
Yeah.
Yeah. So it's kind of hard to.
Yeah, when they designed it, they probably didn't give too much attention to the impedance and trying to match it to the speaker. They probably didn't even care. As long as it worked, it worked. They can sell the product.
Right. I'm sure they try to get as few parts in it as possible to get the lowest cost possible.
Yeah. However, putting a resistor in parallel could still possibly damage the processor on there, right?
Yeah.
If you put, so you can play around, but putting a resistor in series will also lower the volume.
So first of all, you're painting. I'm painting. And if you were there.
I've been lobbying for potentiometers. I mean, a variable resistor would be your friend here.
I think that LPAD idea was a very good idea, actually.
I do too. I haven't looked at the link, but I suspect it's going to be a relatively large device.
But
that may be a problem.
It's predicated on, the LPAD is assuming a specific impedance. And if you had a 50 ohm potentiometer, you could.
I have 100 ohm. The smallest one I have.
100 ohm potentiometer would probably allow you to do some experiments and see what you really need.
So would I start with it in parallel, you think? At 100 ohm, which is not going to have a big
impact. Short it out.
Yeah. It would be bad, severe if you accidentally got too low. So maybe start in series. See what you get.
Okay.
Nice thing about the LPAD is you got both series parallel type things going on.
Yeah, but he may have a space issue.
Yeah.
Well,
here's a description off of Parts Express.
Yeah, I would want to understand what the DC resistance is of the LPAD to get a sense of what kind of current would be involved, which you could then kind of relate to the output capability of the logic gate. I'm going to guess that the logic gate would be very unhappy with more than maybe, small 2 digits of milliamperes. And pending, it could even be way smaller. It could be single digit milliamperes.
So
Hey, Paul, there's an option here. What you could do is get one of these $8 LPADs, connect it up temporarily, and measure then the resultant resistances that it presents once you've adjusted it to what you like.
Yep.
And then just substitute the right resistors in like an HPAD type of hookup.
Okay. So do I have any equipment here that would help me understand this better? I have a bench multimeter which can measure milliamps.
AC milliamps?
I think so. If only I had flashlights so I could see.
I mean, the other piece
DC
of this,
volts, AC volts. And then there's some little blue ones that are function shift things that I can't read in this low light.
yeah, I mean, the other piece of this is that the gate's going from high to low, and there's lots of dancing going on with the phantom ground and or the synth, the pretend ground and so on. So it's kind of difficult, and one or two variable resistors might allow you to just work on, make a practical solution.
Yeah. I'm perfectly fine with something that works, that I don't understand. But
hey, Paul, another thing that we've used in broadcasting were connections called T-pads and H-pads. And sure, they were trying to match impedances like 150 ohm to 600 ohm microphones and things like that. Again, we're talking about microamps and milliamps of current. But you can get as small as dealing with 16 ohms, 8 ohms, 4 ohm type speakers with it.
Hey,
so here's a link to a calculator for that if you ever want to explore that as well.
I got an idea.
Okay.
How about something along the lines of, do you have any potentiometers there that are low resistance?
100 ohm is the smallest one I could find.
That's probably fine. You can start off with that, and the circuit that I'm thinking will never harm the amp, and that is you put the potentiometer, the 2 outside poles, right? Not the wiper.
Yeah.
You put those on the power line. You put the speaker on one power line, and you put the other side of the speaker on the wiper. So as you go down, you're decreasing the volume. As you go up, you're increasing the volume. And
that's just half an LPAD. Yep.
Yeah, you're essentially making something like an LPAD, but not quite. Okay. But you can, after you do this, you can then sit down, measure the resistance of the volume you like, take out the pot, and stick in the right resistors.
Yep. So tell me the connections again. The 2 ends of the pot go.
2 ends of the pot would go to the amplifier directly.
The 2 pins of the output.
Okay.
Of the
amplifier. The wiper would go to one side of the speaker, and the other side of the speaker would go to whatever is ground, or it probably doesn't matter, actually. Well, the only way it would matter is in which way the volume control worked. Okay.
Yeah.
I got to sketch that while we're still here.
Actually, if you had a trimmer, 100 ohms, you could just leave it in there.
Yeah, but what you might discover. Yep, that's perfect.
That's
And
perfect.
you may discover the 100 needs to be a different number.
Smaller,
So-
not larger. So
hard to guess, but
really?
probably smaller.
Okay. Well, one thing, I have an alarm clock near my bed, right? And I wake to music. And I've heard that there are audio taper and linear taper pots, and so I kind of understand that logarithmic versus linear
One's
change
based
in
on the bell
resistance.
curve.
Yeah. And I have that knob, right, almost as low as it can go. And if I turn it a little bit more down, I get nothing. If I turn it a little bit more up, it's too loud. And if I turn it up, it's way too loud.
Right, and that's because it's not an audio taper. It's a linear. So it's not based on how your ears hear. It's based on.
Why wouldn't they put an audio taper in a radio?
They were cheap. They were cheap.
They were cheap.
Audios are hard to find, and a lot of Chinese parts houses don't even bother stocking them.
Yeah, they're hard to find audio taper pots.
Okay.
You only really see them in professional equipment.
Okay. I would love to get that.
So if you don't have a pot that's a low enough resistance, what you can do is connect a resistor from the wiper up to the top connection. So as you move down, you're having the resistance between the wiper and the top, and you're creating a nonlinear curve, which actually would mimic to some degree an audio taper pot.
Yeah, if you have a 100 ohm pot, think about using a 20 ohm or 30 ohm resistor.
Yeah, that's probably a good idea. That sounds good. So, in other words, if the pot is all the way up, maximum volume, that resistor plate has no effect at all.
Right. Yep.
All right. As you move it down, it becomes it's in parallel with the part of the pot that's between the wiper and where the resistor, the other end of the resistor is. So you get a nonlinear change. Yep, exactly.
Okay.
One last thing.
Right.
We were a minute ago talking about sticking your 100 ohm pot across the output of the microcontroller. Theoretically, that's going to, I think you measured 4 volts peak to peak in the with the oscilloscope. Was that right?
4.2-ish.
Yeah. So, I mean, if it really tries to drive 4 volts into the 100 ohm resistor, that's a lot of current. That's 40 milliamperes. Or am I wrong? Somebody correct me. 4 100ths of an amp.
But they're using 2 gates, so you've got
40,
the sourcing and
40,
syncing
40
capability.
thousandths. Yeah. So anyway, just the observation that the.
So should I start with 1,000 watt, 1,000 ohm?
Wouldn't hurt. And fairly quickly. I mean, you just don't want to cause the gate to overheat.
Yeah,
it's the biggest thing.
Hey, Paul, how much room do you think you would like to add circuitry to all this?
Yeah, there's room for another circuit board ish.
Well, I was thinking more of like a 741 or equivalent, 386 or something like that op amp, and just drive the microcontroller output into the op amp and have the op amp drive your speaker.
I'm not sure if the op amp can handle the current.
When he mentioned 386, isn't that a one-chip amplifier? It's not really an op amp. It's an audio amplifier, right? The 386 chip that you mentioned, not to be confused with the Intel 386.
Yeah, the 741 is an op amp. You've mentioned
Right,
that too.
but the three, but
Right.
the,
An LM386. I'm looking.
I don't
up
know.
right now.
I'm not sure offhand.
In radio station use, we used to substitute some later op amps in place of the old.
What is it? An LM 386?
Yeah.
I think I have some
A low
741s.
voltage audio power amp.
Yeah. Now, so there's like line input or line output.
I've used them before for, like you said, line drivers.
So I guess if this is, well, I don't know. I don't know anything about audio. I know that you want to drive, if you have a line output, that's what you want to stick into your amplifier, as opposed to something that's already amplified up or down in volume.
Yeah, I posted the data sheet for that chip on there.
Here's some 741 equivalents.
Well, 741's more of a straight op amp.
Which is what I was thinking actually in my head. Oh, I'm thinking of the 056, the TLO 56 061. So like a TLO 61 is a good substitute, but it has a higher slew rate. An 071 is common.
It's best though to get something that's actually made for audio because it has better protection for shorting the output.
That's why I was thinking the 386. That's why that came to my head.
So
does this have? Oh, there's gain. So these, am I sharing or not?
No.
Nope.
Not.
Okay. Hang on. Let me
that
share
that
again.
piece of cardboard and tape is sounding better by the minute.
So here's the little
screen. Yep, that's the.
This is the schematic. Okay. So this has the voltage and ground. It has an input plus and minus, plus and minus. It has V out, which I assume goes to the speaker. And then it has gain. So is this what would control the volume?
Can I share a couple of equivalent circuits for you?
Sure.
This may have circuits at the bottom. Go to the bottom of that. There you go.
Look at all those components. So I guess this is the volume control.
Yeah.
Pin 3, interesting. 1 and 8 were the gain. Let me go back up and see what pin 3 was. 3. It's the plus input. So they're driving. So this is your signal in.
Right. So they're shorting the negative side of the op amp to the ground, and they're putting the volume on the plus side.
Yeah.
And pin 7, what's that? Because they're not using 1, 7, and 8.
1 and 8 were the gain.
7 may just be power.
7 is a bypass.
That's for like a filter.
Oh, okay.
Let me share mine. I'll show you the quick one that I saw here.
All right.
Can you see that?
Yep. We see it.
Okay. So that's the simplest circuit that I was thinking of right there.
Is that the link that you put in the in the chat window, or not? Peter is. No.
No, that was 741 equivalent. This is the LM386.
Okay. If you can grab
And,
that link and stick it in, I'd appreciate that.
It
Maybe
was
I'll
just a
Yeah, I'm putting all these links in the notes for the
maybe I'll just
video.
do a screenshot here.
It was just a quick DuckDuckGo search.
So his inputs to that amplifier would be the two gate outputs, each of which is a single-ended output. And the question would be whether the 386 input has kind of a basic assumption to do with where ground is.
No. Not really. You can float its ground.
So they have a capacitor driving the speaker in the wire driving
Almost
the speaker.
always.
Yeah.
When you're dealing with these chips, you almost always want to.
Yeah, you don't want harmonics that if well, sometimes it can misbehave and try to put a huge high frequency signal out.
Trying to think some of the other circuits here.
So Paul, I have 4 of these things in stock here.
The LM386s?
Yep. LM386N-1/NOPB, whatever the hell that means.
Are they DIPs or SOICs?
Oh, these are probably through hole, most likely.
Yeah. They're probably 8-pin through hole.
Yeah. Okay.
The thing that I can't get away from is the notion that we've got all the volume we need. You know, why do we need an amplifier?
You got to remember your amplifier can go smaller too.
I mean, this was my more complicated way of solving it, right? It gives you a volume control that actually is on an amplifier instead of trying to jerry rig a volume on the speaker itself.
Call it an active device.
Yeah, but Paul, I'll be honest. I mean, both Scott and I mentioned this type of idea, but I'd go with the pod on the speaker lines first and see if you can get it to do what you want.
Yep.
I mean, with the 386, you can get like as complicated as you want.
So tell me again. So if I just add a resistor in series, let's say, if I add a 0 ohm resistor, I've already got those, right? Those are wires. If I add a 10 ohm resistor, which is roughly the resistance of the coil,
we don't know.
Don't know what's going to happen. So that should reduce the current flowing through the circuit. Well, I'm thinking DC, right?
Well, if you noticed on that 386 circuit, they had a capacitor pretty high, like 250
220, yeah,
microfarads in series with the
speaker. Yeah.
That's going to act like a filter also. And I bet you it's there specifically to kill high frequency crap.
Yep.
If you look at what I've got going here, a simple passive attenuator for what you're doing, Paul, probably I would do it through an H pad, but that's because I'm used to balance and unbalanced. But even a T pad might be suitable enough. And I did some quick calculations, assuming that if you had an 8 ohm speaker, these would be the values of the resistors.
Yeah, well, there's no way to know And I'm almost going to guarantee you that when they designed this thing, they never even cared about matching impedance.
Right. I'm not saying matching impedance, but this is a good way to get an attenuation.
Yeah. I to be honest, I tried the idea with the pot the way we said before.
Yep.
Try that first. See if
Okay.
you can get something that works. You can also just throw a capacitor in series. That may just be enough to kill the high frequencies, which may solve the volume problem
And the tinniness problem.
and the tinniness. Right.
And something in the 200 range, or
Well, I mean,
Well,
you could try that.
You got a capacitor substitution box?
If it's too high, you're not going to get any low frequencies at all through there. So if the capacitance is, I'm not sorry. I'm sorry. If it's not too high, if it's too low, like if it's like 1 or 2 microfarads, you probably get like no low frequencies at all. So you want to get a fairly high capacitance so you can get the whole low frequencies but cut the highs.
get the lows but cut the highs.
I think I said that right. I haven't done
So-
audio work in a long time.
so basically, a capacitor's impedance drops as the frequency goes up. Plus or minus the fact that there's inductance in every capacitor and it's more complicated and blah, blah, blah. But
Yep.
generally, that's the scheme. And a series inductor is the opposite. So with a series inductor, as the frequency goes up, the impedance goes up.
So is the frequency going to be if I measure peak to peak on these things, is that the frequency?
What? No, it's the horizontal. It's the x-axis.
It's right.
Yeah, that's what I mean. If I measure the distance from one of these little spikes here to the next
You
spike.
measure the period, right?
Yeah.
So the higher the period, the lower the frequency.
But really, they're just playing games with the duty cycle.
Yeah.
As it interacts with the impedance of the load. So it's,
Yeah.
I guarantee you, they designed that amplifier with pure empiricism. I'll bet you nickel they never once got their calculator out.
Yeah. They go. Oh, all we got to do is find a speaker that'll take the current that we're going to feed it. That's all we care about, and the right size. So the other advantage of using capacitors is you don't have to worry about frying the amplifier. Anything you put in there, regardless of the size of the microfarads of the capacitor, is never going to fry anything in the amp.
Okay. Other ideas? Anything? I will give this a try. I'm going to the beach next week, and so I'll bring some things.
You'll have to get back to us on this one.
I will definitely. I'll let you know in a month what works and what doesn't.
The other thing is to log the baby's facial expression as your y-axis.
Yeah, they could perceive it totally differently than we do, right? Maybe
A note on the videos on YouTube, since Google is now enforcing ads, or they won't let you watch anything, people are probably going to see ads when they look at any of our meetings.
So there's a way around that.
Well, if we were monetized,
Demonetize ourselves.
How's the way around, Pete?
All
Let's
right.
You
hear
can
the
flag
demo.
it.
Let's
you
hear
hear
the
this?
demo. Paul's trying to.
Oh, okay.
Can't you flag our videos as not appropriate? And they won't get monetized.
That's the toy?
Yeah. That is the
Wow.
toy.
That is kind of loud.
If you play YouTube within the Brave browser,
Brave. I don't never heard of a Brave browser.
Yeah, it's a really cool browser, and they have some magic that filters the commercials. If you have an Android phone, you can install an app called Newpipe, Newpipe, and it will play YouTube videos with no ads. So there's still
put those two on the chat real quick.
Oh yeah.
I'm debating on whether or not I want to put these in the description on YouTube. They may not like it.
Do you think they're going to read this?
LPads and all that?
No, the LPads are fine. It's how to get around YouTube stuff.
I don't think any human's going to read it.
Well, a person may not, but an AI might.
Okay, so I think that's enough for the problem of the month. Show and tell. I know that Charlie wanted to show some stuff. Perhaps he can go first.
Yes, that's it. Thank you. So yeah, this is the next version of the robot. Oh. So I machined it on a Shapeoko 3 extra large. The outer shell is 1/2-inch polyethylene, high density polyethylene, and the inner shell is 1/4-inch. The next version is going to be all 1/4-inch because the 1/2-inch is a pain in the butt to machine and also twice as expensive. All of the edges are welded, which took forever, and that's one of the things I'm changing in the next version to make it more manufacturable. But the net result is something that's very, very tough. I welded the edges, strangely enough, by taking a panini press, sticking a slug of high-density polyethylene in between a piece of parchment paper, panini pressing it, hot air on the surface, because what I learned from experimenting with this is they both have to be hot. The cold plastic will not weld to hot plastic. So you gotta get them both hot. So panini press, hot air gun, then you take it out, slam it on there as fast as you can, and then take the excess off with a knife and then use a manual planer to get nice afterwards. I've got my own board at this point that, have any of you ever used VEST motor controllers? Yep. Basically this combines 4 different brushless motor controllers into this one board, as well as 5-volt regulation and 3.3-volt regulation and lithium iron phosphate battery charging. There's a gigantic battery underneath this, and this is all driving 4 hoverboard motors. And the net result of this is something that shrugs if you stand on it. It doesn't even deflect even a little bit. And you could whack it with a baseball bat, and I'm not sure it'd notice. And is strong enough that I've had the other version that I showed last time that carried me up a hill just fine. So it's got an onboard Jetson Nano to do the computation, GPS, and a wide-angle camera in the front. So I'm making a new version that's incorporating some new strategies and some new technologies. This was folded rather than welded.
Cool.
So I got a plastic folder and I've been experimenting with that. And one trick I came up with is that you can score it, where you just do a millimeter thick cut into it. And that'll make it so even if you're not exactly precise with the melting, it'll still bend along that exact line. One of the problems I've run into is that the plastic melter or the plastic folding machine that I've got, tool I've got, is not really made for melting plastic that's a 1/4 inch thick. It seems to stall out at about 1/8 of an inch. So I adapted some sheet metal manufacturing techniques and worked with basically spring back, where you melt it and then you effectively have thinner plastic that doesn't particularly want to be folded all that much. So you overfold it, and then it springs back as it cools down, or after you set for like 2 minutes. So the net result is I can cut this piece in about 5 minutes per piece, and then the folding is about 5 minutes per fold. And so I'm going to go from having to weld each of these lines, which was a huge pain in the butt because I had to add a ton of material to it, and go from that to instead having one sheet that I cut out all in its entirety, which also reduces the number of parts I need to machine. And then I just fold it 4 times to make the outer shell and then seal the edges. I think for that, I'm going to switch to having it so that the pieces fit together very nicely, and then basically heat up a hunk of aluminum to the right temperature and just shove it against it, and then cool it down with water once it melts the plastic sufficiently. So I'm hoping to get the whole thing down to like less than 6 to 8 hours to construct the whole thing. Because I mean, I got this circuit board assembled externally, and the price is not unreasonable. And so altogether, I'm trying to make it so that this is an open source robot that is really easy to customize. I guess I didn't talk about that. So right here where I showed the Jetson Nano, I know the camera isn't great, but there's a GPS here that can pop out and pop back in. And underneath that is the Jetson Nano and the wide angle camera. So I'm going to make it so that, well, for one thing, I'm going to move the GPS to the other side so it's a bit less in the way. But I'm going to take this whole thing and make a pair of pieces that fit together. This has not been fully debugged yet. I'm actually due to machine another version of it here. So, but we got 2 pieces that fit together, one of which is going to hold the Nano and the other one's going to hold the camera. And so whenever you want to access it, you can just pop it out, just pop out vertically, and then pull it apart, and you can access all of the surfaces, which that feature came in mind because it was very difficult to get the Nano in there the way it was. The other technology besides the building that I'm incorporating in the next design is inserts. So you'll see this have a screw sticking out of it. So I'm hoping to have it so that you can just screw in the Jetson Nano in the camera with brass inserts that are already in there. So once I get the next version of the chassis and the next version of the printed circuit board, I want to add a differential amplifier to make the battery charging a little bit more precise. And there's one trace I need to expand so that even under high current draw, it doesn't heat up. But otherwise, it's already working. So once I get a new version of the printed circuit board and the new version of the chassis, I'm going to open source all of this. And I'm going to try and get as many people involved as possible, and either give out robots or sell robots, or just try and get people on board with it, and try and make this really customizable, and start assembling a big reinforcement learning data set where people can do offline reinforcement learning to make a robot that can go from point A to point B.
Why?
To our first point, you need to be out at the Hamfest because that's perfect. Perfect to show off to others, perfect to get other interest in. And the fact that we're going to have a couple other robotics groups or robotics parts of maker spaces there, that'll be great. So we need you out there. We need you on your table.
Well, I need to talk with my wife to make sure we don't have any other dire plans or weddings that day. But barring that, I will try and make it.
I mean, that's perfect.
Yes, let me.
Yeah. Is there a reason why you're building this like a brick latrine?
I have done robotics research a fair bit over the last 8 years. And one thing that I noticed when I was working with the aerial drones was I was really scared to try anything because the drone would die very, very fast if you mess anything up. And so, being young, inexperienced, and frankly pretty broke, I was terrified of breaking anything. I also had my dad try and help me collect some training data at one point, and within 5 minutes, he crashed my platform into a bench. which broke a bunch of stuff. So if there's anything I've learned, is that if you're doing any sort of research or any sort of long-term operation, you really want it built sturdy. Because it's going to crash into things. Also, one of the intended operating environments is a golf course, so it will get hit by golf balls and possibly golf clubs too. Never know.
People may find it irresistible to stand
As a
on it,
target. Yep.
or to stand
Yes.
on it.
Well, we saw the video of you sitting on it once, an older version, as it was moving.
Yes, that was a 1/4 inch version of this. The new version, actually, can I share my screen?
Sure.
Yes. It's the third from the left thing. It's to the right of
Yes.
The screen with the arrow in
the
it.
video mute.
Precat and allow. All right, can you guys see?
Yep.
So here's the new version of the chassis that I'm working on. It adds a number of new things, one of which is the front piece that I was talking about where you can just pop it out really easily. It also adds a piece to the battery from flying out if you manage to just flip it upside down and shake it. So far that hasn't been a problem, but it's made me nervous. And yeah, so this doesn't have the side reinforcements like the current platform and the next one. So that will reduce the strength a little bit, but it's 1/4 inch high density polyethylene. And it's got this reinforcement here. I'm still fairly confident it will be able to handle someone standing on it just fine.
What kind of plastic is that?
This one has exterior of 1/2 inch high density polyethylene, but all the other ones were 1/4 inch, including the one that I sat on and had borrowed last time.
HDPE.
HDPE.
Yes, high density polyethylene. You know those garbage buckets that you cart out from your house?
Yep.
Ah,
Same thing.
Oh, it's that stuff. Okay.
very tough.
Yeah, it's very
Yes.
tough. That stuff, though, the garbage buckets, though, are much thinner.
Yes, they are. This is meant to be strong, shall we say.
And do you have any provisions for current limiting with respect to the battery circuits?
Mostly I've been relying on the fact that it seems to be handling the current draw fairly well. I haven't run into any issues where the battery seems to be struggling with it thus far.
I was thinking more in
there's
terms of accidental short.
You mean with the motors, or which part of the circuit are you talking about?
Well, the connections to the battery, whether or not
it actually does have, the battery itself has built-in short protection. So if you short circuit it, it will just stop acting like a battery within it. Basically, you'll get a bit of a spark and then it'll just cut out.
That's great. Yeah.
So it's over current and under current, or over current, under voltage.
I mean, that would be a major sales point when you talk to folks who have been watching Teslas catch on fire.
I also selected the most safe battery chemistry around.
Yeah.
So that's my idea. I'm hoping to work with a 3-tier business model where I sell hardware and I help other people make accessories for this. Like if you're trying to use these inside, I could see you wanting to swap out. 3-tier model. So this is an open source project. All of the hardware is going to be completely published as soon as I get the next version done. All of the stuff for the printed circuit board, all of the firmware, all of the software, all of it's going to be open. Published, anyone can collaborate on it. I've got Discord where people can talk about it. But for people that don't want to take all of that and CNC machine it and do plastic bending and all that stuff, I'm going to be trying to sell this at $1,500, which is, hopefully a revenue source, as well as if anyone wants to make accessories for it, then here is the profile that you need to meet. And if you want to try and see whether or not your thing's going to work out, happy to sell you just parts that you can pop in there and you can drill your own holes and see whether or not your sensor does what you think it'll do. And then after that, the level above that is a traditional open source software company where there's all of these different companies that are trying to make a delivery robot that's theirs and it's mine. I'm going to be the only one that has access to any of this IP. I haven't really seen anyone doing open source with that. And it seems like with all of these different players trying to do that sort of thing, but keep holding it so close, we're sort of blocking a potentially really useful technology where no one really has access to it. And a lot of people are whacking their heads against a hard problem and nobody's collaborating. So I'm hoping to collect some really big open source data sets of basically this trying out different deep learning models and probably crashing into a ton of stuff, which is part of why it's built really sturdy. And then publish those data sets so that anyone can take a crack at with their own deep learning models and have some competitions, seeing who can model how soon am I going to crash? How soon am I going to crash? How soon am I going to crash? Because I've found with my investigations into this with imitation learning is that if you can just label the data right, saying, okay, in this spot, this is what you should have done, deep learning models can learn that really, really well. And you can deploy some remarkably compact models and get some pretty darn sophisticated behavior if you have enough training data and correctly labeled training data. So the big machine learning problem, I think, for this is essentially sequence prediction. If I'm here with this history and I do XYZ things for the next 5, 6, let's say 3 seconds, am I going to crash? Will I get closer to my goal? Like the GPS updates every fifth of a second, more or less, and it is possible to get faster than that. So as far as reinforcement learning problems go, you're getting pretty quick updates in terms of reward versus penalty. And I've already written the navigation software that will compare it to a GPS map and say how far you are from where it thinks the sidewalk is. So as far as machine learning problems go, I think it's both potentially tractable and really interesting. And I think that a open source approach to solving this, going from point A to point B without crashing into anything, could be really interesting. And if we can crack the fundamental problems, I think that opens up a lot of fun, interesting applications, both for hobbyists, like the crabapple project that Paul's talked about a few times, and more general things like precision agriculture, where if you can get the hard stuff out of the way, then deploying your own interesting problem or solving your own interesting problem on top of that gets a heck of a lot easier. And maybe if you approach that on an open source way, then this could be useful for that too. You could build something up with other people. So I think that by having a base model, it could help encourage collaboration there. And then the last for my company, and perhaps others as well, is the person who wants to use delivery robot technology to do something, but they're a golf course owner. They don't want to mess with any of this technology stuff. They just want something that works. And I think if you combine the end product of the first two, then I or other people could take these robots and walk over to a golf course and say, hey, for $5 a day, I'll rent you this robot. Someone presses a button in the app, orders from your old clubhouse, and it rolls on out. No person in a golf cart required. Or half a dozen other applications or places that I haven't thought of. If the design's open and anyone can manufacture this, or even just buy one and see whether or not their particular idea for where this could be useful works, more power to them. So.
I'm thinking applications like farmers and checking for various things out in the field. I'm thinking of scientists where they're looking for specific chemistries or specific materials embedded down in the ground, having the ground sensing equipment that they're trying to, move back and forth. All that fun stuff. Maybe even some automated, what is that? Ground penetrating radar type things.
Mm-hmm. I think it could be really useful for that sort of thing. And I think a lot of groups are wasting a lot of valuable time solving the same problem again and again and again.
And most of what I've seen scientists and folks use now is a hand-pushed cart as opposed to something that's automated.
Right.
Yes.
Paleontology, for that kind of thing too.
Yeah, and there's some groups, like there's a group over at NC State that has been working on a wireless platform and a rover for it But a lot of times these academic groups will come up with a prototype that'll do the job and they'll publish a paper on it, and then it just gets sitting on a bench somewhere. Whereas I think with something like this, if you have a base platform and they could just make, and here's our little adaptation that you need to add to this base platform, hey, that's a product. They don't have to make the entire robot and support all of the manufacturing and production for the entire robot.
Yep.
So if you get the $1,500 package, how much headroom is there on the Jetson board with respect to, say, memory and storage and processing power?
Depends on what you're trying to do.
No, I mean, I send you a check for $1,500, and you
Mhm.
send me something, and I unbundle it and I turn it on. What is it packed full of code and storage usage such that you need to be thinking about an additional processing power or additional storage?
I think as long as you're, well, frankly, the software is not as in a high acceptable enough state that I would, right now I'm mostly going with the physical model in this development path forward. But if we're talking about the imitation learning model that I worked with, it's eating up most of the GPU and probably about 2 threads of CPU. But if you're running anything CPU wise that's not super intensive, you should be fine. If you're doing something deep learning, then you're going to be fighting with the other deep learning model. Like, this is not the strongest machine, and I think that would be very reasonable and very acceptable to have variations on the base model where it's like another $200 or $300, but you get a nicer NVIDIA GPU board. Though NVIDIA has been upping their prices for that a lot, so there's issues.
So there is a migration, a relatively painless way to get more headroom.
Yes, very distinctly. Again, I'm making it so that you can pull out the sensors and the computers, just pull out, pop it out, pop another one in. The only connection between the high-level logic and sensors and the stuff that's hard installed onto the robot is through a UART connection. That's it.
The Nano is what, 199, is that right?
At one point, one model of it was $65, but those days are long gone.
And so they have a Xavier Jetson, which I think is closer to $800 that they sell for self-driving cars and things.
And they have a Orin Nano.
Yeah, the Orin one is, and they're working on even more capable ones. So there is a pathway, and almost all the software should be pretty easily portable between the different flavors.
Yeah, it might be good to do a slightly. I know that you could go to the Orin Nano and not have any space issues, but if you go up to like the full scale Orin, I think you might start running into actual issues having enough space to fit the computer itself.
It's got a much bigger heatsink and stuff on it.
Yeah. So you may need to have an alternate chassis to be able to make that work. On the flip side, you can expand this chassis and switch out the motors and change all of that stuff. And all you need to do is make the wires connecting to the brushless motor a little bit longer. That's it.
So if there was the need for some additional computational unit, right? Do you have APIs and protocols set up so that there would be a way of, for example, tying into some awareness of what's going on with the sensors and the motors that are in the base unit?
So there's a pretty strict firewall between the high level, not firewall, but there's a defined pathway between the high level computation and the low level computation. The low level computation is done on a ARM M4, if I remember, or sorry, a STM32 G0 chip, which does the PID control for the motors, handles the recharging. Basically, all of the low level control is handled on that chip using a GBOS based firmware. So that's all right here. you talk to that from your Jetson Nano or your or in Nano high-level computation through UART, and you say, I want this speed on this motor, I want this speed on that motor, give me the readings from the GPS, give me the current motor speed for each of them. You're talking by a established protocol.
So you've got just a pure serial communication protocol as opposed to something like, say, a Modbus, which would be on the serial UART.
Yes.
But
Or
the Modbus is
ROS.
actually defining registers and various information.
No, it's just pure serial communication with a predefined format. It's actually based on a modified version of the PPP communication protocol. And I will provide a library so that you can say, I want to set motor 1 to this speed, and they'll say, okay, and give you a live stream of GPS updates and motor speeds if you want them. As well as, battery.
On another project I worked on, they duplicated like Motorola PLCs, has a serial interface and command interface and readings back from the PLC. They utilized that whole model in another whole situation, and it's the same kind of communications back and forth. And basically, it's how you define the header, the payload, and the checksum for the communication packets.
Yes. Again, it's using modified PPP for the link layer, and then the actual messages you're sending back and forth are in message pack, which is a pretty well established message serialization format.
Okay.
With lots of different language findings. Yeah. That's my project. What do you guys think? Any recommendations for changes or?
I want to see one. I'm a little concerned about the tires. They look like they'd be great for golf courses and sidewalks. Not
Stay
so
away.
good.
Stay away from battle
the
line.
rough. Yeah.
Which part? Where do you think it'd be rough?
The rough at the golf course, right, where the grass.
Or say in a farmer's field, those tires are too small. You almost want like small bicycle type tires spread out.
This is one of the things where when I'm ordering 5 of them, it's kind of hard to get the manufacturer to work with me. But if the orders start getting bigger, it gets a lot easier to change. The other thing is you have to remember that all the weight, these are hub motors. So a great portion of the weight of the robot is in these wheels. And so it has a tendency to just sort of power through whatever it hits into.
They look kind of slick. So I can imagine, if I wanted to drive it around the fence lines of the horse pastures with a weed whacker for trimming it wouldn't get very far, and the wheels would be spinning, and it would get high centered, or
I suspect you would be surprised with how well it would do. It is 4-wheel drive, and I have driven it a fair amount. Deep mud can be a problem, and it doesn't handle snow too well. But other than that, it does pretty well.
I was just thinking when you've got ground with a lot of ruts in it and clumps of dirt and stuff hidden underneath the grass.
What's the ground clearance?
Kind of bumping into it.
Let's see.
2
Let me measure
inches,
that
maybe?
real fast.
About 2.
Yeah.
2.5.
Apologies, one moment. This thing's heavy enough that I don't really want to let it go too much.
You can do it in hands. Like horse people do. That's one hand. It looks like about one hand.
If I was to estimate, I'd say about 50 millimeters or so.
2 inches. Yep. Okay.
About 2.5 inches.
So, well, 50 would be less than 2. But anyway, how many watts are do the motors use?
I need to calculate out. They're being run at 12 volts, so I need to hook up my current sensor on it. But I've gotten run times, depending on the terrain, of between 4 and 6 hours.
I was just trying to imagine what, fraction of a horsepower was on each wheel to guess whether or not it could go up inclines pretty well and that kind of thing.
It took me up a hill.
Cool.
But yes, that needs to be measured out more precisely, and yeah, it handles pretty well.
How wide are the wheels? Are they flat or is it a curved wheel?
The wheels have a little bit of curve, but once you've
Yeah.
been driving it for a little while, it tends to wear flatter. In terms of the width, give me a moment. It's about 40 millimeters.
Oh, okay. Is it possible to put a wider wheel on there?
The wheels are basically solid metal. So I think a wider tire would be very good. But again, I've not really had the negotiating power with the motor companies I've been working with to get that as of yet. I'm very much small potatoes, but I'm hoping if I can actually get this into production, that's one of the things I can negotiate with them is, hey, let's see how much big of an effective wheel we can get out of this.
Yeah. So a wider wheel will give you better traction, right?
Mm-hmm.
That's what I was thinking of.
Yes.
Better clearance, better traction.
Yes. The only difference here is that the motors are external; they're built into the wheel itself.
Yeah. Yeah, he's
So,
using
I mean-
hub
Okay.
motors.
I see.
Yeah.
So,
So in terms of the power these things can put out, like 2 of these can drive a human around, and I've got 4. But I'm running at 12 volts rather than 36.
Yeah.
The issue I ran into is that basically the hub motors that you can buy are either this size or not motorcycle, skateboard size. And there's not really much
Just
in between.
smaller, yeah.
And the next increment up is like bicycle size or wheelchair size.
Oh. Yeah, so yeah, in your case, the solution is you keep the wheel more or less, but increase the width of the tire on the wheel.
Yep.
Mm-hmm. Yeah, because it's got plenty of power.
Yeah, it's not the power I'm thinking of. It's just, I mean, if you go over slick grass, it may not go up a hill.
It goes up slick grass just fine. I'm more worried about damage to the grass than I am about it not going up. But I've personally driven it up pretty steep inclines as well as on grass. Because the thing you need to remember is most of the weight is both variable down and distributed into the wheels. So its center of gravity is very low, which helps a lot with the inclines, and it's got power to spare. And frankly, worst case scenario, it also has a tendency to dig it down until it finds something solid. So I'm more worried about damaging the golf course grass than I am about traction.
Is there a name for your project?
GoodBot, and I have a Discord which I can throw in the chat if you guys are interested.
GoodBot.
Oh, you have a Discord server. Okay.
Yes.
That's cool.
I made one last week. It's got 3 people in it besides me. So let me grab a fresh chat. And throw that in. So yeah. I'm hopeful that this will be the sort of project that people like, and also that multiple people make money with. Because again, I think the real money is for the selling to the non-technical end user. and doing alternate pricing models like renting or selling with a service plan, et cetera, for the people that just don't want to deal with this.
I'm
Or
sorry,
building software on top of it.
what's the name of
Expecting
the
to have
project again?
I think that was fully. Go ahead.
What's the name of the project again?
GoodBot.
GoodBot. Okay.
Mm-hmm.
You spell it as one word or two?
One.
Capitalized to B?
Yep.
Okay.
And if any of you are going to see it in person, I'm happy to drop by and show it off. I need to port the firmware or the high-level logic from the old platform to the new platform, switching from steering with one stick to steering with two, because I want to make it easier for the reinforcement learning algorithms to imitate it, etc. But yeah, the hardware is all working. I just need to port over the software.
All right, who's next? I got my RPM sensor working with my pickleball display, and then I hooked in a little local display, and I'm going to try to get that packaged up as a small little unit that I can carry to the shop so I can check the RPM of some of the machines that don't show you specifically what the RPMs are. Other than that, I've been playing pickleball and.
Did you see the Super Bowl ad with the little babies?
I did. Those weren't real pickleball paddles, but and it was funny. It was funny. The ad. There were two different ads, but one of the ads starts off with these very serious players, hitting balls back and forth, and then they swing to the other side and show the kids on the other side. But I could tell when the serious players were hitting the ball. I could tell which ones were going to go in the court and which ones were going to go out of the court, which ones were long. That's one of the skills that you develop as you play pickleball long enough, is that almost as soon as it comes off the paddle, you can tell whether it's going to go out or not. And, you know whether to duck out of the way to let it go or reach to try to catch it. And so a lot of their shots were going out, I could tell. So it's interesting, as I play more pickleball, I have more time to think and plan and decide where I want to hit it. When I was just starting, it was this flurry of activity, get my paddle somewhere in the right area, and over time you become accustomed to some of these things.
That makes sense.
According to my brother, that sort of happens in racquetball too.
And it happened to me in volleyball as well. Just about as I stopped playing, I was getting to the point where, as I was going up to do a spike, I could see the opponents and figure out where the right place to hit it was, and then I quit playing.
I mean, that's fairly normal, isn't it? With the trained activity, cognitive load decreases as you get more experienced with it, which allows you to do higher level processing.
Yep.
I think there's a phenomenon in when I took this class way back in college about muscle memory and being able to push down automated things. That's why, you see police departments and military and all those do all the training and exercises over and over and over again, so that some things become more automatic and now they can concentrate on more of a higher level view of what's going on and being able to spot changes and make adjustments.
Yep. That's why people drive home and they say, How did I get here? I don't remember any of the trip. All right, anybody else have show and tell?
Well, I don't really have any show and tell. I've been working on a project for a long time here, but it's strictly software. Has anybody ever done any work with calendars? Because that's what I'm in the midst of right now, and they're really complicated.
Really? Because when I did that back, I want to say 30, 35 years ago, it wasn't that big of a deal.
You just talking
If
about
you do
Gregorian
the-
calendar kind of stuff, or you talking
If
about
so, okay, so here is
Outlook
what I'm doing.
calendars?
Gregorian calendar is strictly an arithmetic calendar, and it is fairly simple, but it's not accurate. However, I've mentioned before that I'm a Baha'i, and we have our own calendar called the Badi calendar. It's a solar astronomical self-correcting calendar, extremely accurate, but the math will drive you crazy because everything's based on the vernal equinox, which is why it's self-correcting. So every vernal equinox starts the next year. You have to know what the longitude of the sun curve is. And that's 360 degrees in a year. So you have to figure out the day. So a regular day is a little bit more than 1 degree. And this stuff can get very complicated. So the Baha'i calendar by itself is very simple. The problem is when you have to start converting between calendars. That's when things get difficult.
Yep, exactly. I remember trying to go back and forth with the Mayan calendar and with the Chinese calendar.
So I got this book, and they actually have the math in here for the Baha'i calendar. One of the guys that wrote it is a professor at a university in Tel Aviv in Israel.
There should be a Python library for that.
An email asking them, "Can I use this stuff?" And they said, "Yeah, sure, whatever you want." So, but they actually do conversions. It's all their code is in Lisp, and it's a very old version of Lisp, which is almost impossible to get to run now. He gave me his GitHub address, so I can look at this stuff, but I have not been able to run it.
This sounds like a job for ChatGPT if I ever heard one. Translate this Lisp code into some other
I use
language.
ChatGPT all the time, but the best ChatGPT can do is give me hints on how to solve problems. And it can do some minor conversions between code, but I'm not trying to convert code directly. I'm trying to convert the concepts. And that's not always the same thing as saying, I'm going to take this line of code and then write it as this line in Python. That's really you wind up with copies that don't really work quite well.
But you're absolutely certain no one has a published library for this? Because this is like the definition of if you can find a library, you should find a library.
Right. I have done a lot of searching for that. I found a lot of people. I've even found other Baha'is who have tried to do this, but they've all done it with. So this gets complicated because in 2015, the Baha'i World Center in Israel decided to, well, they didn't decide to. They knew they had to do this eventually. They took it off of the Gregorian. In other words, it used to sit on top of the Gregorian. So they said that's not the way it's supposed to work. It's supposed to work by the vernal equinox. So they made the center of everything to be Tehran, Iran, because that's where the founder of the faith was born. So, so I have to figure out the vernal equinox and sunset, because that's when our day starts at sunset, not at midnight. And we're not the only calendar that does that. There's a lot of them out there that do that. But this, getting all of this stuff to line up and figure out what day you're in, because one starts before the other one. And then the Baha'i day is never the same because it has to go by sunset to sunset. And that time can lengthen or shorten over the course of a year. So this all gets pretty complicated when you start to do conversions.
Do you have unit tests where you check to make sure the dates you expect to line up?
I'm sorry. What was that, a question?
Surely there's some known dates where the 2 days are going to coincide, like you can
Oh,
look up the
well,
conversion.
I know what the epoch is, or the epoch, if you want to call it that. I know what the epoch is of all the different calendars. That's easy to figure out. Okay. So, I mean, technically the Baha'i calendar started at sunset in 1844, March 20th. And the next day was 1844 at sunset, March 21st. So that I know. So all of this stuff is done using the Gregorian period, which is not the Gregorian calendar.
We are.
Okay. So the Gregorian calendar is what was screwed up in 1453 or something, and they had to add 11 days because they were using the Gregorian. That's the Julius, not the Gregorian, the Julian calendar after Julius Caesar. The Gregorian period is a point in time that is a count of days until the present. It isn't usually calculated in years, months, and days. It's just days. But it does have a leap year of every 4 years, but it's not a complicated one like the Gregorian calendar is.
That's the Julian calendar you're talking about. The Julian calendar.
So it copies a
you
lot of
calculate
stuff
by
in the
days.
Julian calendar, but it's not the Julian calendar. It's the Julian period. And this is what all astronomers use to do anything having to do with astronomy, which is why I need to use it.
Exactly. As a matter of fact, it's the same calendar that you see all these calculations for, for the Christians, for Easter and Christmas,
Right.
for the Chinese, for the light, the New Year. It's that Julian period thing that you're talking about.
Right.
And it's the pure calculation of days.
Yeah.
I remember, in fact, that's the Cal program, CAL, that we did for Unix. It got posted in the regular Unix and got posted all over the place. I think Linux might use a variation of it now.
I use Cal all the time.
Yeah, that's if you look at the source code for it, it starts with the Julian calculation first, and then everything comes from there.
Yeah, just type CAL and whatever year you want. If you just type it Cal by itself, I think it gives you the current month. Yeah.
But I programmed that originally back in '81.
You're the author of this?
I was the second author of it. I took somebody else's work that wasn't working, and I modified it as a part of my employment when I was at working for the department at Purdue.
I'm looking at the man page. I want to see if I see your name in here.
I don't know if they do or not anymore. It's been a long time coming.
Well, this says FreeBSD, who published it.
Yeah, now see, that was '88. So we did this in the BSD much earlier. FreeBSD derived it later.
Yeah. Yeah, I've been using that a lot just to get a basic idea of what day is when.
I may have my original source. It's long since been modified.
Yeah, I've been using the let's see, who is it? Oh, JPL, NASA government. They have a Julian date time converter, which I've been using to verify some of the.
Check out the NIST calculator as well, NIST, the National Institute of Science and Technology. But that's where I got my original calculations and stuff from.
Who is that again?
The National Institute of Science and Technology, NIST. NIST.org, I believe.
If you want to go really crazy, you could get one of the orbit simulators and try and redrive the.
There you go.
calendar based on the planetary positions.
So what year did they skip 11 days?
It depends on what country you're from.
Yeah, that's true. Every country did it at a different time.
Does Cal know about that or not?
Yep, it did. And it used your locale variable and everything to adjust it differently for your country.
I'd like to see the calendar for the month in which it goes from whatever the third to
In
the
some countries, there was like
14th.
11 days taken away in September. A couple other countries, there was. It ended up. I think America was the last one to switch over, and it was. I want to say 13 or 14 days, but they took it out of September. A lot of the governments took it out during September.
Anyway, I just brought this up because it's been a really interesting project. I haven't. It's the math itself is not complicated. There's just a lot of it. So it basically is. There's a lot of trig, geometry, and algebra, and that's pretty much it. There's no calc in it really. There's summations, a lot of summations. Kind of cool stuff. But I'm writing unit tests for some of the code that I wrote. So I've had to use all these online calculators for different things to verify that my code was generating the right, like sine waves or degrees around, the solar longitude. I had to verify if that actually worked right. So I use a lot of code from this guy's book and how to convert the Lisp to Python. But there's bugs in there, and I'm afraid to say anything to him because these two guys are professors. I don't have a PhD. So I don't, it's kind of weird. I don't want to tell two professors, guys, you got some bugs in your code.
No. Go ahead and tell them. They'll appreciate it.
Ask if they can explain that section because they're a little bit confused.
Yeah, make it turn it around. So in one place, they're converting universal time from standard time. And in order to do that, if you think about it, all you really have to do is know the time zone, right? However, since you're doing it in days, counts of days, you can't just add the time zone or subtract the time zone because that's in hours, not in days. But that's what they were doing. You had to convert it to a fraction of a day and add or subtract that depending on which way you were going. And so that's one of the bugs they did is they forgot to convert hours to a fraction of a day. That's one bug. The other bug is their solar longitude wasn't correct. If you went across the different years, you'd find a year. So what happens is solar longitude should always be 0 at the vernal equinox, which is around March 20th or so. Okay. But it could be various times of the day. It has to be there. But if you put in a date of March on a given year with theirs, you'd get 180 degrees out of phase. It would actually be somewhere like in September or October or whatever it is, 6 months later. And this is a really big bug. They didn't write that code. They borrowed it from somebody else. So I found that guy's book and his stuff was wrong. Had the same bug. So, man, I've been doing tons of research.
Sounds real familiar because I remember spending several days getting that thing straight.
Well, this hasn't been several days. This has been over a month already working on this. Over a month. Because I got to deal with a couple of different calendars. I got to deal with the Baha'i calendar, got to deal with the Gregorian, got to deal with the Julian period. and I may have to deal with the Islamic calendar, because there are 2 Baha'i holidays that we still use the Islamic calendar. Eventually, it'll all be on the Baha'i calendar, which means that now those days are shifting around. Somewhere in September and March, they keep moving around because the Islamic calendar is a lunar calendar based on the moon. So it's
now you know what the Jews and the Coptic Christians, or the
yes,
I want to say
the
actually
Jews
the
have their
Orthodox
own calendar. Is it an Islamic? I mean, Israeli calendar.
Right.
Oh, they deal in this book with close to 30 calendars. There's a lot of calendars out there. Luckily, I don't have to deal with all of those. I only got to deal with 2, maybe 3 or 4. It's still pulling my hair out doing this stuff. You notice my beard's getting thinner?
Yeah, I know Chinese New Year was the hardest calculation to get straight.
Yeah, they do that in here. Matter of fact, the Chinese calendar is also a self-correcting calendar, but it's not solar, it's a lunar calendar.
Right.
So it's perfect on the moon. It ain't perfect on the earth. The Baha'i calendar is a solar calendar, so it actually is always correct. We still have leap years, but they don't coincide with the Gregorian. So this year is a Gregorian leap year. Our leap year is not this year. I think it's like another 2 or 3 years away.
The moon is slowly leaving the Earth. Something like by an inch a year.
It's moving away, which means its orbit is getting bigger and it takes more time.
Right. So it's actually mussing with all the lunar calendars.
Yeah.
Compared to 5,000 years ago.
So here's actually a list of stuff that I got from the Baha'i World Center, where they have it figured out from 2015 to 2064. But that's all. So, I mean, I could use this and make everything a lookup table, right? But you're not really figuring out what anything is. And if I have to figure out something in a partial day, that doing lookup tables isn't going to help me. So I need this for the bookkeeping thing. So I can record all the bookkeeping stuff in Baha'i months. And there are 19 months in a Baha'i calendar. And between the 18th and 19th, there are 4 or 5 days, depending on leap year. So there's actually 4 or 5 days which are not in a month. They're their own thing. They're called intercalary or intercalary.
Have you looked up the proposed metric calendar they were talking about? A year of 10 months, and there was something like, I forget exactly, but like each day was 20 hours, and
so they're going to change how long an hour is?
Yeah, how can you do that? Oh, well, you'd have to change how long an hour was, right?
Or
well, that's what it is. If you're doing 10 months, I mean, the same thing with the Baha'i calendar. We're changing everything.
Actually,
we're not changing the day.
They're modifying the definition of a second, which screws up a whole bunch of other calculations in a bunch of other worlds. Wow. And then once they do that,
we're not doing that in the Baha'i calendar. We're changing the focal point to Tehran. So instead of it being UTC in what do you call it?
Greenwich,
right? It'll be Tehran. So our time zones will go from Tehran, not from London or Greenwich.
There's another town in like South Africa or something that lines up exactly with Greenwich on the longitude.
Oh, really? Yeah. So
the southern hemisphere folks, the
latitude is zero. It's only the reason why it's a man-made concept, the whole thing.
Right.
It's
all arbitrary.
They said it is. It's all arbitrary. So they said our longitude is zero. The only thing that changes from here is our latitude is zero. Only thing that changes is the longitude.
No, I think it's the opposite.
Longitude is zero.
Latitude is horizontal, like the equator. Longitude is north to south pole.
The lines of longitude go through the poles. Yes.
Yeah. You're right. So the longitude
So that's
changes
kinda
depending on
arbitrary.
where you are in the world. So that's the one that's zero. The latitude isn't. You're right. Latitude has I think it's like 54 or something like that. It's dot
Greenwich.
something. Anyway, the only reason why I brought it up is because this is all kind of cool stuff. Dealing with dates is, to me, is kind of fun, but it's also making me lose beard hair.
You need to grow it out longer, like I've done.
Yeah, I used to have it a lot longer when I was younger. I've had a beard pretty much since I was in high school. Shaved it off a few times. For a while, I just had a mustache, but in general, the beard's been here almost my entire life. I even dyed my hair once.
You could always shave your mustache and keep the beard and go the Amish
Oh,
look.
God. Man, that would look terrible.
All righty. Well, thanks everyone for joining, and we'll see you in a month, if not
All righty.
a little sooner at the Edger meeting.
See you later.
Bye, Nate.
Bye-bye.